At Ingevity Pavement Technologies, everything we do is interface science. For us, it's all about what's going on at the interface, or rather the boundary between two substances. The interactions that are occurring at a molecular level when two media, solid, liquid, or gas, meet. Our mission is to use chemistry to affect what happens at those boundaries. And amazingly, when we do, water is cleaner, dyes disperse better, asphalts mix and compact more efficiently, and we do all this with renewable resources. Of course, the big question is how? Well, we actually create special molecules that enable a sort of chemical harmony at the interface. But to explain how those special molecules work, we'll need to go back and review Chemistry 101. You probably all remember that big chart that hung on the wall of the high school science lab. It's the periodic table, a cheat sheet of sorts, that categorizes all the unique atoms or elements that make up matter: hydrogen, sodium, carbon, nitrogen, oxygen. Now you will recall that when atoms combine, they form molecules. For instance, when an oxygen atom bonds with two hydrogen atoms, it creates the molecule H2O, or water. You'll notice the structure of the molecule. The oxygen atom has an excess of electrons and is negatively charged. The hydrogen atoms have fewer electrons, and they are positively charged. The molecule has poles, much like those on our planet. And these poles make the molecule polar. Molecules with a more equal distribution of electrons simply cancel each other out and are nonpolar. And this is important because polarity affects solubility, the ability of two substances to mix. So if we mix polar H2O molecules with other polar molecules, let's use ethanol, the two substances mix. The alcohol is soluble in water, and nature likes this combination. You see, polar molecules like to be with other polar molecules. But if we go back to our periodic table and we make a nonpolar molecule, like cooking oil, and then we mix our oil molecules with our water molecules, and I'm sure you know where this is going. Oil and water don't mix. Nature doesn't like this combination. Nonpolar molecules only like to mix with other nonpolar molecules. They may temporarily disperse, but the oil molecules stick together and the water molecules stick together. And given a little time, all of the like molecules will find each other. But what if there was a molecule that had both polar and nonpolar characteristics? A molecule that could bridge the great divide between the two. Surfactant chemistry, coming up next.